Welcome to AP Statistics. Today, we are diving into topic 1.6, describing distributions for one quantitative variable. Our learning objectives are to 1. Describe the shape, center, variability, and unusual features of a distribution, and 2. Justify claims using graphical representations of data. By the end of this lesson, you will be able to look at a graph and tell a complete story about the data it represents. We will focus on the key characteristics that statisticians use to communicate what a dataset looks like. To remember everything we need to cover, we often use the acronym CUSS, which stands for Center, Unusual Features, Shape, and Spread. Let's break these down one by one. Let's start with the overall shape of a distribution. When we talk about shape, we are looking at the big picture of how the data is grouped. Our goal is to identify and describe the shape of a distribution. The first thing we look for is symmetry. A distribution is approximately symmetric if the left half is roughly a mirror image of the right half. However, many distributions are not symmetric. They are skewed. We say a distribution is skewed to the right or positively skewed if the right tail, toward the larger values, is significantly longer than the left tail. A good trick is to remember that the skew is where the few data points are. Conversely, it is skewed to the left or negatively skewed if the left tail, the smaller values, is longer than the right. Now we've defined the basic balance of the data. Next, we'll look at how many peaks the data has. Beyond the balance of the tails, we also describe the modality of a distribution, which is just a fancy way of saying how many peaks it has. Our objective is to identify modality and recognize uniform distributions. If a distribution has one main peak, we call it unimodal. Think of uni meaning one, like a unicycle. If there are two prominent peaks, it is called bimodal. This often happens when the data contains two different groups, like the heights of both men and women, combined into one graph. What if there are no peaks at all? If the frequency of every value is approximately the same, we describe the distribution as approximately uniform. It looks like a flat rectangle. Take a moment to look at this graph. How would you describe it? Since it has one peak, it is unimodal. Since the tail stretches to the right, it is skewed right. We have now mastered the vocabulary for describing the general flow of the data. Now, let's look for the things that stand out as strange. The second letter in our CUSS acronym stands for unusual features. These are the parts of the graph that don't fit the general pattern of the rest of the data. Identify outliers, gaps, and clusters. First, let's talk about outliers. Outliers are individual data points that fall a significant distance away from the rest of the distribution. They are unusually small or unusually large relative to the other observations. Next, we look for gaps. A gap is a region in a distribution where there are no observed data values. Gaps are important because they might suggest that the data comes from two different populations. Closely related to gaps are clusters. Clusters are concentrations of values that are grouped together. When you see clusters separated by a gap, it's a major signal to investigate why the data is splitting into these distinct groups. We've now identified how to spot the oddities in our data. Always remember to mention these when describing a distribution, as they often tell the most interesting stories. The final pieces of our description are the center and the spread, or variability. These give us a sense of where the typical value is and how much the data varies. Identify the center and variability of a distribution. The center is the middle of the data. For now, you can estimate it by looking for the balance point or the median value that splits the graph into two equal areas. Now we're moving on to variability, so we must clear the existing graphic. Spread, or variability, describes how much the data values vary from each other. If the data is all bunched up near the center, it has low variability. If it is spread out across a wide range, it has high variability. Now, let's put it all together with a worked example. Imagine we are looking at the distribution of scores on a difficult math test. To describe this, we must use context. We would say, first, the shape. The distribution of test scores is skewed to the left and unimodal, with a peak between 80 and 90%. Next, unusual features. There is a gap in scores between 30 and 50%, and the single score near 20% appears to be an outlier. Finally, center and spread. The center of the scores is approximately 80%, and the scores show high variability, ranging from 20 to 95%. By combining these elements, you've provided a complete statistical picture. You are now ready to justify claims using these graphical representations.